today's video. In today's video, we are going to be solving recurrence relations using generating function. So let's get right to it. So first, let's write our generating function, which you could term g of x equals the sum to positive infinity of k equals 0, a exponent k, x exponent k. Then the next thing is you multiply through your recurrence relation by the highest subscripts, which in this case is k. So a k x exponent k equals 5 a k minus 1 x exponent k minus 6 a k minus 2 x exponent k. And then we then have to sum everything individually. So then we sum, and then since our given values were a0 and a1, then the sum must start from k equals 2, since these are our initial conditions. So we sum this from k equals 2 to infinity, and it's positive infinity. ak x exponent k equals, since 5 is a constant, it would not be included in the summation. K equals 2 to infinity, positive infinity, of ak minus 1 x exponent k, then minus 6, you do the same thing to infinity, k equals 2 ak minus 2 x exponent k. And then there is a neat trick you could do at this point. So you find the difference between the starting point of k and the subscript of a, and then in this case it's 2. The difference between this k and this is 2. So then you need to subtract 2 terms from your generating function g of x. So g of x minus, so the first term is a0, and then the next term is a1x, and you know that this is ak plus 0, so since it's a 0, you don't multiply by any x, so then you leave it as it is. So equals 5. So then in this case the difference here is 1, so you just subtract 1 term from your generating function. So g of x minus a naught, and since there is a 1 here, you multiply by x raised to the power, so then x raised to the power 1, which is just x, then minus 6. The difference between this k and this k minus 2 is 0, so you don't subtract anything from your generating function g of x. But then since this is a k minus 2, you multiply by x squared, which is x to the power 2, so x squared. So now we could then expand. So we have g of x minus a naught minus a1x equals, so this would give us 5x g of x, 5x g of x minus 5x a naught minus 6x squared g of x. So then we could group the g of x's to one side and the other terms to the other side. So here we have g of x minus 5x g of x, and then plus 6x squared g of x equals, then we take these two terms to the opposite side. So we have a naught plus a1x minus 5x a naught. So then we could factor out g of x from this. So we have g of x, then 1 minus 5x plus 6x squared equals, so a0 is 6 plus a1x would be 30x minus 5 by a0, which is 6, would give us 30, so this is 30x, sorry, minus this would also evaluate to 30x, sorry for that. This is a x, so these two would subtract and would give us 0. So then we then divide by this quadratic equation. G of x equals, so here we have just 6 remaining, so 6 all over 1 minus 5x plus 6x squared. So we could then factor this quadratic expression, so this would give 6 all over, then factoring this out, we should get 2, so it will be half, and then so 2x minus 1, and then 3x minus 1. So that's what g of x. So then this is now a partial fraction, so we could then solve it. So let me rewrite it down here. 6 all over 2x minus 1, 3x minus 1 should equal a all over 2x minus 1 plus b all over 3x minus 1. And this, you should remember from partial fractions, which are partial fractions of the first order. So we could multiply through by this 2x minus 1, 3x minus 1. So then when we multiply through, we get 6 equals a by 3x minus 1 plus b by 2x minus 1. So then we could then expand. Let me take it to the other side. So 6 equals 3ax minus a plus 2bx minus b. So then we could group the like terms. So 6 equals, and then factorize 3a plus 2b, all multiplying x, then minus a plus b. So then, since the left hand side should equal the right hand side, we could conclude that 3a plus 2b should give us 0, and then a plus b should give us minus 6 because of this negative, minus 6. So to solve this, we could multiply this second equation by 2. So 2a plus 2b equals minus 12. And then we could subtract this equation, which I'll term as 1. This is 2, and this is 3. We could subtract equation 3 from equation 1. So 3 minus 2a would give us a, 2b minus 2b would be 0, which equals, so 0 minus 12 would give us positive 12. So a is 12. So then we could then input an a into this equation and solve for b. So b would be equal to minus 6 minus a, which is minus 12. So b equals minus 18. So then we could then input it into our partial fraction. So g of x would equal a is 12 all over 2x minus 1 plus minus 18 all over 3x minus 1. So to simplify it further, we could multiply this by minus 1 over minus 1 and this 2 by minus 1 over minus 1 to make it look like one of the generating functions we know, which I'll write this here. So it looks like this. So k equals 1 to infinity of x exponent k should gives 1 all over 1 minus x. So let me write this here. So our goal is then to make these two terms look like this. So then we could then, that's why we are then multiplying by minus 1 over minus 1. So g of x should give, so then we could, since this then becomes minus, it's just right to take it to the other side, to the second side. So multiplying this by minus 1 over minus 1, multiplying this by minus 1 minus 1, which doesn't change anything, but then we just want it to look like this form. So we could write it as 18 all over 1 minus 3x and minus 12 all over 1 minus 2x. So then we would write these two, this first fraction and then this second fraction, to look like this summation here, which is equal to this. So then in this case our x here would be 3x, and then in this case our x would be 2x. So g of x would equal, so 18 could come out since it's a constant, then sum of k equals 1 to infinity, and note that they are all positive infinity. So our k here is 3, our x here is 3x, so we have 3x at the power of k minus 12, then with sum to infinity, k equals 1. Then here in place of our x we have 2x, so 2x exponent k, and then it's not negative because the negative, it's already here, then it's catered for by this summation. So we could then expand. So I think after this line I'll have to move here. G of x equals 18 sum of k equals 1 to infinity of 3k xk. So from now on it's just purely algebra. To infinity of k equals 1, so 2 exponent k x exponent k. So now we could bring the summation outside and then factor out x at the power k. So then it's then now, so line here. So g of x would now equal, so we are bringing the summation out, k equals 1, since they are the same, and then have a bracket. So then the 18 would multiply this 3 at the power k, so you have 18 by 3 exponent k, then minus 12 by 2 exponent k, and then we are factoring out x exponent k, so x exponent k. So the reason why we did it like this is to make it look exactly like our generating function which we started with. So our main goal is to solve for a k. So then now, since this would now be our ak, So we could now conclude that conclusion. A k equals 18 by 3 exponent k minus 12 by 2 exponent k. So then this is our solution using generating functions. Yeah, I wrote it. It looks like this is a k, like this. So these are the steps you take whenever you want to solve a recurrence relation using generating functions. I hope you enjoyed the video, and I hope to see you in the next video. Please be sure to like, subscribe, and turn on the bell icon to be notified whenever I post a new video, and comment if you enjoyed the video. See you in the next installment.